In the late 1990s, a series of mysterious metallic fragments, often referred to as Art's parts, captured the attention of the UFO community. To the naked eye, they looked like strange, broken shards. One side was dark, granular gray, while the other was highly reflective, mirror-like silver. But the true anomaly was revealed under magnification. At the edges of these fragments, scientists found perfectly alternating microscopic layers. It was a precise stack of bismuth separated by thin bands of magnesium-zinc alloy, measuring just a few microns thick. This intricate layering led researchers to suspect the fragments were a metamaterial, a structure engineered microscopically to manipulate electromagnetic waves. While standard materials scatter a wave, a metamaterial's geometry bends, channels, or absorbs it in highly controlled ways. The problem was that no one in the conventional aerospace or chemical industries could identify a use for it. At the time of its discovery, no known commercial or military application required alternating magnesium and bismuth at such a delicate scale. When terrestrial manufacturing couldn't provide an answer, a vacuum of understanding formed. Without a clear human origin for this specific engineering, the theory took root that these fragments were the byproduct of advanced extraterrestrial technology. To understand why scientists took this extraterrestrial hypothesis seriously, you have to look at the unique properties of bismuth itself. Element 83 on the periodic table is remarkably heavy, and its nucleus possesses an unusually high quantum spin state of 9/2. That specific atomic configuration makes it highly useful in theoretical physics. Researchers proposed the Terahertz Waveguide theory, suggesting that exact micron-thick layers of bismuth could allow very high-frequency electromagnetic radiation to travel perfectly through the material. What makes this waveguide model so compelling is the scale. In this theoretical setup, the bismuth layers are able to channel wavelengths that are up to 20 times larger than the layers themselves. That capability is a signature of deliberate metamaterial engineering. There's another, more speculative layer to the bismuth theory. Bismuth is a group 15 pycnogen, placing it directly above a much heavier synthetic sister element on the periodic table, element 115, now known as Moscovium. Element 115 carries significant weight in UFO lore. For decades, it has been the exact exotic fuel that whistleblowers claimed was used to power recovered alien anti-gravity reactors. This led to a fascinating forensic hypothesis. If these fragments aren't actually from an extraterrestrial craft, they might be a terrestrial mock-up, an attempt by human engineers to replicate the exotic physics of element 115 by substituting it with its closest stable relative, bismuth. Before committing to the idea of classified anti-gravity research, we have to look away from the physics of intentional design and examine the realities of industrial metallurgy. This brings us to the Betterton-Kroll process, a well-established method used heavily in commercial lead smelting. When raw lead is processed, it often contains bismuth impurities. To remove them, smelters add magnesium to the molten lead. The magnesium binds with the bismuth, creating a solid waste product called dross, which floats to the surface so it can be skimmed off. While lead smelting creates a crude mixture, there is a second, far more precise industrial method that utilizes these same elements: magnetron sputtering. Sputtering is a high-tech technique used for thin film deposition. Inside a vacuum chamber, argon plasma is used to bombard a source metal target. This knocks atoms off the target and sprays them onto a specific substrate, creating an incredibly thin, even coating. In a vacuum chamber running both bismuth and magnesium targets, the metallic spray that misses its intended target lands on the chamber walls. After hundreds of hours of operation, these stray atoms build up into the same micron-thin, alternating layers seen in the mysterious debris. This reveals a critical blind spot in the extraterrestrial hypothesis. Advanced human industrial processes create highly complex, micron-layered metallic structures entirely by accident, producing industrial waste that mimics intentional atomic-level engineering. When we look back at the physical anomalies of the UFO fragments, the pieces fit. The rough, granular side and the undulating, uneven growth patterns of the layers are exactly what we see in the accidental accumulation of overspray building up on a rough machine surface. The chemical evidence provides a specific explanation for the fragment's makeup. When a sputtering source is composed of 99% magnesium and 1% zinc, the argon plasma doesn't remove the atoms evenly. Zinc atoms are ejected, or sputtered, at a higher rate than magnesium. Because these zinc atoms are liberated more easily, they make up a larger percentage of the resulting buildup than they did in the original source. This specific physical interaction consistently results in an accumulation with a ratio of 97% magnesium and 3% zinc. This 97-to-3 distribution is an exact match for the chemical signature of the arts parts fragments. The material shares a fingerprint with the discarded waste found in high-end human manufacturing. While that might seem like an anticlimax, there is a profound scientific twist here. Even though the fragments were industrial slag, the speculation surrounding them correctly identified the incredible physical potential of bismuth. Today, mainstream material science is deeply invested in bismuth. Researchers are actively working to exploit its unique quantum spin and waveguide properties to engineer actual, functioning metamaterials for next-generation technology. We don't need crashed saucers or mythical elements to explore the boundaries of exotic physics. The elements required to manipulate the physical world are already here on Earth. Sometimes we just stumble upon them, hiding in plain sight as the accidental marvels of human industry.
If you're passionate about science, technology, AI, and the unknown, subscribe, share as we explore tomorrow, today.